Hello, everyone, and welcome to the webcast, How to Securely Access Compute Resources in Cloud Environments, sponsored by Gravitational. I'm Tracy Cook with ADTmag.com, and I'd like to thank you all for joining us. Before we begin, I'd like to cover a few housekeeping details. Following today's presentation, we'll host a Q&A session. Please get your questions ready, and we'll answer as many as we can. Gravitational has provided some links for you, so please take a look. They're on the console, and we hope you take the time to check them out. And finally, this entire webcast is being recorded and will be archived for future viewing, and we'll send you an email when the replay is available, and that should be in about 24 hours. So now on to the webcast. Joining us today is Virag Mody, technical writer at Gravitational. Virag, thank you so much for joining us today. We're in for a very interesting webcast, so take it away.
Yeah, great. Thank you, Tracy. Hi, everyone. My name is Virag Mody. As Tracy said, I am a technical writer here at Gravitational. I want to thank all of you for taking the time to attend this talk on how to securely access compute resources in clouds. Now, this talk is largely based on a white paper that we released about a month or so ago, which has gotten a lot of attention from some pretty big companies like IBM, Dell, Palantir. And so we decided that maybe we should do a webcast as well. And so for the most part, this talk is going to remain conceptual, but towards the end, we'll take a look at why SSH certificates are safer than SSH keys through the lens of the principles that we learned throughout this webcast. And my goal is that by the end of this talk, not only will you have some principles to better tackle this challenge, but also some techniques with which to apply them. So before we begin, just a little bit more about Gravitational. I won't take too long here. We're an open source company. We have two main products, Gravity and Teleport, both of which are open source. And much of this talk is inspired by Teleport, which lets developers securely access the tools they need without getting in their way. Basically, Teleport is a gateway that stands between you and your servers, your Kubernetes clusters, and in another month or so, also web apps like Jenkins or Salesforce. And users can enter this gateway by signing into their SSO provider, and Teleport will automatically apply permissions and controls based on the information about the user stored in their IDP, whether using Okta, Auth0, Keycloak, what have you. And so you can set rules like developers can't access production environments during working hours. If you're interested in learning more, there's some links towards the end of the presentation and some that Tracy shared in the console. So let's get into the fun stuff. The first thing I'd like to do is define our topic a little bit more. So when I wrote this title initially, right, how to securely access compute resources in cloud environments, it just seems kind of buzzwordy. Working from home. So why don't we narrow down the scope a little bit and really figure out what is going on here? The first thing is secure access. What do I mean by secure access? I just mean any type of way to reliably authenticate and authorize so we know who is accessing what resource and what are they allowed to do. And authentication, authorization, they're not new by any means. Right? Even in the world of networking, we've had passwords for decades at this point. But the context in which I'm talking about secure access is authenticating and authorizing against a much richer data profile, not just a password, not just a hexadecimal string. And we'll talk a little bit more about where this information comes from and how it can be used. The next segment is compute resources. So what are compute resources? That's just any type of infrastructure resource that has some type of processing capability. So in cloud environments, most of this is virtualized, right? We're talking about servers, clusters, applications, databases. But there's also that hardware element, right? You have your desktops and perhaps any other devices that might be part of your network. And then finally, cloud environments, which sort of seems the most self-explanatory. We're just talking about hybrid, multi-cloud, VPC, but more broadly, I'm talking about any type of elastic environment that focuses on providing high availability and has resilient architecture. And so another way to say how to securely access compute resource in cloud environments is how to authenticate and authorize access to elastic infrastructure. So how do we know that this is actually a problem, right? How do we know I'm not trying to just sell you on some vaporware nonsense? So there's two trends that I want to point out. One is the abstraction of the IT stack, and the second is the decentralization of these compute resources. And I think this image by Gartner on the screen here really captures this sentiment well. You have all these different like X as a service hosting solutions, right? And what they do is they take these different elements of the IT stack, these different layers, and they compartmentalize them. They abstract them using microservice and orchestration. And so you have this extreme sense of compartmentalization abstraction, where everything is neatly packaged and is ready to deploy on any server anywhere in the world. And it's a similar concept with decentralization, right? You might be spinning servers up and down. If one of your regions has an outage, you need to spin servers up in another region, or maybe say your West Coast servers needs to fetch data from the East Coast. God forbid, maybe you're using like edge devices, right? At that point, you've sort of expanded your network by like orders of magnitude. And so abstraction and decentralization isn't a problem on its own. In fact, it lets teams move very quickly and do a lot more than was ever possible before. But the way that we set up and enforce access policies isn't designed to be compatible with ephemeral infrastructure. The principles that we base our access policies on are assuming some degree of static infrastructure with discrete groups of people that we know that are going to be requesting access. And I think nothing sort of demonstrates this fact more when we consider that we rely on networks to do this for us, right? We expect networks to authenticate and authorize, to distinguish between who is trusted, who is not, with which we then decide what access policy to apply. So when I talk about networks, I like to think of this concept of the map is not the territory. So what does that mean? Well, it means the map is not the territory, right? The map is an abstraction. It's a representation. It is a substitute for the territory. So in this case, a network is an abstraction of what we think is happening, what we think users and machines are actually doing, what their behavior is. But that's not the same thing as what they are actually doing, right? It's a substitute. It's a representation. And so when we look closer at what we're asking the networks to do for us and what they're actually capable of doing, we start to see some of these incongruencies. So for example, infrastructure was a lot more static in the past, right? That's something that we can all agree on. But what we would do is we would use substitute variables as a placeholder for behavior. We would use IP addresses, ingress ports, basic authentication patterns as substitutes for what we thought was actually happening. And that was fairly reliable because things were static and we sort of knew where traffic was coming from, who that traffic belonged to, et cetera. But nowadays, those variables are constantly changing, right? Infrastructure is very, very dynamic. And so for the network to keep pace with what's going on in the territory, in the system, there needs to be a constant updating of firewall rules, routing rules, IP tables, access control lists. And yes, you can automate that as much as possible, but ultimately there will be a lag. There is always going to be some delay in what your network is telling you and what is actually going on. And that doesn't make network security irrelevant by any means, right? That's not what I'm saying. I think network security, if anything, is going to become more important, especially as like cloud computing continues to sort of grow into its adolescence. But relying on the network to tell us what is actually happening, with your resources needs to change. Substitute variables aren't sufficient anymore. You have to track the actual behavior. So that brings me to this slide, which is arguably the most important slide of the deck because it answers the question of how do you securely access compute resources in cloud environments? And the answer is to separate the processes of authentication and authorization and let the resources themselves enforce the access policy, not based on network information. So how do you go from this network model to something that looks a little bit more like this? Well, I mean, you start by applying these 4 principles. These are the principles that we built Teleport on, and they're the principles that we believe are required to securely access modern infrastructure in modern environments. So the first and probably the most important principle, which is why it's the first, is to base decisions on identity and not secrets. Another way to say that is to grant access based on who and not the what. And there's good reason for this, right? I see secrets as having 2 major issues. The well-known issue, the one that all of us know, is that if a secret falls into the wrong hands, it can be used maliciously and cause some type of irreparable damage. But the lesser-known the lesser-known weakness of secrets is also the fact that a secret isn't a reliable source of authentication, right? Because originally secrets are meant to be a one-to-one mapping of a person to that secret, right? You issue a person to the secret, and that's really it. But that's not how things work in reality, right? Secrets are often shared all the time, especially when talking about distributed environments, right? Like, are you going to issue each developer their own unique set of credentials for each instance you start? Like, no, that's not viable. You know that they're going to share those secrets. So when a host is presented with a secret that it can validate, the person that's standing behind that secret isn't always the same person that the host is supposed to validate, is supposed to accept. But the host doesn't know that, right? They just have a hexadecimal string that they validate and they let the person through. And so just by presenting a secret, you've both authorized and authenticated in the same step without really knowing who the client is. And so that brings me to identity, right? Identity is a much richer profile than a dumb secret. And so there's a lot more information that you can use to authenticate, right? You have my team, my role, my group, the date, the time, and things like that. And you can't share an identity, right? You only have one identity. I am Virag, no one else is. So how do you actually act on this information? Well, the first thing is you need an identity store. You need a centralized location where you can reliably source identity information that's accurate, that's truthful, and that's up to date. And we all have that, right? Many of us are using IDPs. Active Directory has been a thing for the longest time. Maybe you're using Okta. If you use open source solutions, you might be using Keycloak or Glue. But the point is, having an identity store takes the burden of authentication off of the network, because you've outsourced this process of authentication to an entity that is supposed to do exactly that, right? It's meant to authenticate, or that's one of its purposes. And so your identity store becomes a single source of truth for all of this identifiable information. Now, moving on to the authorization side, there's quite a few benefits there as well. So the identity information that you're pulling from your identity store can help enforce pretty granular controls and permissions, right? So with identity, you can prescribe certain groups, certain roles, certain privileges, all associated with that identity. You have your intern group, your SREs, your sysadmins, and all those identities have their own set of variables, their own set of identification information. And so you can create these enforcement policies that derive its instructions from the identity information and not just from, again, a hexadecimal string. And so you can say, again, very specific things, like I mentioned earlier, devs aren't allowed to access prod environments during working hours, as well as, any permutation of that. And that's not something you can do with the security. That's not something you can do with the key. You need to have a detailed profile of who the client is. So the next practice is just make it easy to use, right? I think if you're attending this talk, you've likely heard of the term DevSecOps. And whether you think the concept is accurate or BS, it's not really the point. What's important to recognize is that developer teams are busy. They move quickly, they have multiple deadlines, they're pushing dozens of updates in a day. That's DevOps, right? And so if you want to make it, if you make it difficult for them to access the tools that they need to do their job, they're going to create backdoors, right? They're going to hard code secrets into applications. They'll generate private keys that you don't know about. They'll share keys that aren't meant to be shared. And so even if you have the most well-intentioned and the strictest security controls in place, if those controls are complicated or inconvenient, you're inevitably going to create a less secure state. For example, I have a friend the other day who works at a prominent banking company, right? Like a multi-billion-dollar market cap. And we were talking about how they access their web apps. And he said, like, to access Jenkins, they set up a VPN, they put in a change order that needs to be approved. They switch from their employee account to a provisional account, which then they have to enter a password that has been generated by some access management tool just to get it. That sounds awful. I don't think any developer wants to deal with that, right? And the workflow is such a hassle when all you're trying to do is look at a dashboard. And so if there's an easier way to do that, they'll find it, right? These are developers. They're smart. And so the second principle is just make it easy to use, okay? Just make it developer friendly, and the systems that you put in place will act as they're supposed to. The next principle is don't trust private networks, right? Just assume there are no private networks, only public. And that may seem like a drastic point to make, but I don't think it's really far from the truth nowadays. We exposed our private networks more and more to the public domain, the public internet, right? We have multiple APIs that we use. We have X as a service, these public cloud-driven applications that sort of make the bread and butter of our systems now. And so more and more, we're increasing the surface area of our internal network that gets exposed to the public. And that makes it much more difficult to assume we can distinguish between who is public and who is private, right? Who is allowed to enter and who is not allowed. And so if you get away with this idea of private networks altogether, it solves two very important problems. The first is just having poor internal protections, right? Having poor internal network security. So let's assume that we can have a private network where we know that the people entering the network are allowed to be there, right? They've sort of made it past the bouncer. There shouldn't be a need for strict internal controls because that person if that person is not representative of who the network is allowed in, they shouldn't be there in the first place. But as we know, that's, again, not true. That's not how the real world operates. And I think a great example of that, the one that I like to use, is the 2014 Target hack, where hackers were able to enter Target's internal network. And they moved horizontally. They went from HVAC data processing, which is provided by a third-party vendor, all the way to payments processing. And they stole a bunch of credit card information. And those two units, those operations, right, are entirely unrelated. There's absolutely no reason you should be able to go from HVAC data to payment processing. But if you assume that everything is public, you're going to have to bake in controls that by default, you just assume that no one is safe, right? You have to assume that everyone is malicious, and you'll never expose yourself to the possibility of having someone enter your network and then move horizontally, move vertically, and get to somewhere that they're not supposed to. The second advantage has to do with encryption. So encryption best practices say to encrypt all the time, everywhere, end to end, right? Data in transit, data at rest, data in processing, just encrypt all of it. But again, if you assume that people within a private network have made it past some degree of security scrutinization, those measures become a little bit more relaxed, right? Maybe you don't encrypt data in processing, or if data is in transit, you don't encrypt that. But again, if you assume that there are no private networks, your default mode of operation is encryption all the time. And the final principle has to do with centralizing your auditing and monitoring. And I like to think of logging almost as like a hygiene habit, right? You could think of this as similar to maintaining like poor Git habits. If you have poor Git habits, then as you grow and as things get more complex, it's only going to become more difficult to unravel that giant knot. And the same thing is true with logging habits. And nowadays, it's extremely important to make sure that you centralize your logging. Mainly because there have never been more logs to collect than now, right? You have server logs, VM logs, application logs, container logs, Kubernetes logs. And so every time you spin up an instance, even if it is for just like 5 minutes at a time, you're basically creating an entire cross-section of the IT stack of logs. And it's very easy for that stuff to get lost in the noise because it's just 5 minutes, right? But those 5 minutes can contain extremely important information. And so similar to identity, you need to find a place to centralize all that information where you can aggregate, parse, analyze, dispose of, whatever. Just keep it all in one place. And this isn't just a security concern, right? Going back to this idea of DevSecOps, you have developer teams that working with security, working with operations teams, right? And so they need to be able to operate on the same information. There needs to be information symmetry. If all of these logs are siloed in their own location, it's going to be difficult to make any type of informed decision, cross-functional informed decision about what needs to be done. And another advantage that I think is important to mention has to do with compliance. So nowadays, compliance is almost the cost of entry to a lot of different markets. You have your SOC 2, your HIPAA, PCI, GDPR, and having some type of centralized logging and monitoring is almost a prerequisite to pass some of the certifications. You don't want to get audited with your pants down, basically. So recapping a bit before we move on to the next section, the way to secure access to your infrastructure is by separating the processes of authentication and authorization and letting the resources themselves enforce those access policies. And to demonstrate this, I think for the remainder of this talk, before we get into Q&A, I want to take these principles and apply them to SSH certificates and take at why SSH certificates are a safer alternative to keys. And I think intuitively we sort of all know that, but my hope is that as we look at certificates through the lens of these 4 principles, you'll see why these principles provide a very powerful framework to think about this problem. So just to summarize what certificates are, I think for the most part, we all know, so I'll keep it brief, but SSH certificates are just another way to connect to a remote shell, right? They serve a similar function as keys in that sense. But unlike keys, certificates have multiple properties. They have identity information, they have principals, they have permissions, they have expiry dates, and then all this metadata as well that keys don't have. And another advantage of certificates, almost a feature, is that you don't have to track the keys that are generated. All you have to do is track the keys for the certificate authority that creates the certificates. And you can harden those locations, right? You're only talking about a couple private keys. So instead of having this like laundry list of authorized keys or known hosts, all you need to do is have the public key for the associated certificate authority. And you'll know that if a certificate is valid, if it's been signed by the pair private key, associated with that certificate authority. It's something that you can authenticate. So here is just a standard look at what like an open SSH certificate may look like. And going through here, just taking a look at what we have. At the top, we have the certificate's public key. Below that, we have the public key of the certificate authority used to sign that certificate. Below that, we have the key ID. The key ID is just an alphanumeric string that gets logged whenever a user presents their certificate. So in this case, we've set it up to be a company email address, one of my colleagues, Gus, which uniquely identifies who the certificate belongs to. This is the identity information I was talking about, right? It gives you visibility into who the certificate belongs to as opposed to a key, which doesn't contain that information, right? You don't know who that key belongs to. And we can even like revoke this value if you wanted to, right? So we can set permissions that gus@gravitational.com is not allowed to present this certificate. And so if you have an employee that leaves the company, you can just revoke that. And it's a simple process of like onboarding and offboarding. That sort of goes back to this idea of like making it easy to use. The next field here is the validity, which basically tells us how long the certificate is valid for. These certificates are basically valid forever by default. So you can use an expiry period as a way to like limit access and ensure that certificates aren't used in perpetuity, which is not something, again, you can do with certificates. The next section here are the principals, and their principals are basically like your Linux or Unix users that the certificate is allowed to authenticate for. But more importantly, again, it's just more identity information, right? You know what groups a particular user belongs to all in one certificate. You know, with keys, you would basically need to issue a key for each user, but with a certificate, you can aggregate them all into one credential. And then extensions, they permit or revoke certain privileges. So on the screen right now, you see sort of like 5 permissions, any of which can be revoked. And so you have this permutation of possibilities. Again, that's not something you can do with keys. Keys are, they don't really have that feature. So let's evaluate the certificate against the 4 principles that we had discussed earlier. So base citations on identity, not secrets. When certificates are issued to the user or to the host, they have uniquely identifiable information, right? These certificates can show an identifiable key ID as well as the principles that the certificate is valid for. You can further subdivide these certificates into groups with like special restrictions like port forwarding or like agent forwarding. And once you have a certificate authority up and running, your certificates can automatically be generated and integrated into some type of like DevOps tooling. So for example, like when you need to dynamically open a shell, you can grant a certificate with the right permissions based on an email, right? And encoded within the certificate is expiry. So you don't have to worry about the secret lying around unattended. It will eventually expire, and you no longer have this liability just lying around on someone's local machine. In terms of like zero trust or not trusting private networks, if you create a certificate authority for both your host and your user, your host and your client, you've now successfully created a closed loop that contains that can authenticate both the host and the client. Right? You don't need a VPN, which, as we mentioned before, if you assume that these private networks exist, you can become complacent. In fact, something that we sort of advocate for is that you shouldn't need to use a VPN at all. Which again may seem kind of drastic, but personally, that's where we sort of see the industry moving. And finally, in terms of like centralized logging, all of your requests are going through a single certificate authority, or maybe a couple if you have your host and user certificate authority separated, which I think you should. Meaning that you basically have this central bottleneck that aggregates all this log information. And so fields like key ID, principles, they all enrich the logs much more than just a simple key string. So again, the purpose of this exercise is to basically frame why SSH certificates are better than keys in the context of these principles, right? We intuitively know why, but if we look at these principles, it becomes a little bit clearer. And if you're still like uncertain, which you have every right to be, you should definitely be skeptical about whenever someone tells you about security things, right? But try the same exercise with your current setup. ask yourself the questions. Am I basing decisions on identity or secrets? Is it easy to use? Am I trusting the network to do something that it can't reliably do? Where are my logs going? If you can rethink how you answer all of these questions, see if what you come up with, what you end up with, is better than what you originally had. Yeah, so I guess that actually concludes the presentation. So as I mentioned earlier, this talk is based on a tech paper. So if you found anything interesting, if there's anything you want to recap, feel free to check it out. And if you are accessing servers or Kubernetes clusters or your web apps and you think they're in need of modernization, check out Teleport. It's open source, and we have some pretty good documentation as well. So with that being said, Tracy, I'll pass it over to you for Q&A.
Great, thank you. Thank you for all that information. Really good presentation today. And I'd like to remind the audience, we do have some time for questions, so please send them in and we'll answer as many as we can today. So here's the first one. What are popular ways of sharing short living certificates? Email, Slack, etc.
Yeah. If you set this up correctly, I don't think you need to share certificates. You'd basically generate a unique certificate per user, which is something that you should be able to do fairly automatically. But if you're talking about like how the user can receive their certificate, yeah, I mean, you can set up scripts that send them over some type of like workplace tools, but you can also just store them locally in your .ssh folder.
Okay. How can I exactly switch from using key to certificate?
I mean, you'd start by basically creating your certificate authorities, right? So as I mentioned, you should have two separate certificate authorities, your user and your host. You don't want all that power in one place. And so yes, you create your certificate authorities, your user and host, and next you'll want to create or like choose a schema for how your certificates should be issued and what type of information they contain, right? Like, will your key ID be an email? Will it be a group? How long will certificates last for one principal over another? And if you want to get detailed, I mean, you can write scripts, right? You can, like, for example, you can have a certificate authority issue a certificate to log into production servers, which is only valid for like 2 hours. And so for authentication, all you need to do is load the certificate authority's public key into your known host file or your authorized key file, and SSH sort of does the rest. I'd also recommend setting up a bastion host to force all access just through a single entry point. That's actually pretty easy to do when you're using proxy jump. So if you want to learn more, we actually have some pretty good articles on this topic. Feel free to check out how to SSH properly and SSH configuration on our blog page, which is gravitational.com/blog.
Okay, thank you. Great answer. Here's another question. It's pretty interesting. It's a little long, so bear with me. We've disabled SSH access to our K8 clusters. I get why, but because they are different sets of credentials, but having SSH access is useful. So they're asking about a workaround. What workaround do you suggest for this?
Yeah, so if I have this correct, you're saying that you've disabled SSH access to your Kubernetes clusters because you have to like track these sort of two sets of credentials, which should be necessary if you have like kubectl, right? Yeah, that's a great question. It actually goes back to my point about identity, right? So if you can map authentication back to an identity provider where you're not relying on Kubernetes or SSH to do the actual authentication, just based on like a secret, then, sorry, lost my train of thought here. What you're basing is if you're using identity information, you're synchronizing your access policies to and tying them just to an IDP. So you basically you can have a role in Okta called admin, right? That admin role should map to an admin principal for SSH and an admin Kubernetes groups. If you're using unique sets of credentials, that's not exactly possible, right? Because you're not sort of tying them to a single source of truth. And so if the logic is that, we have kubectl access, we don't need SSH access because that's just another set of credentials you need to worry about, that's not necessarily true if you can base the authentication authorization on some more concrete, richer information like identity.
Okay, great. Here's another question. It's about your open source solution. It's how does your open source solution solve this problem?
Yeah. So I had mentioned this earlier on in the talk, but Teleport is basically just like an access gateway, right? What it does is that it pulls information from your identity provider, which is then used against an access policy, which is enforced by a teleport daemon that lives on the servers or on the Kubernetes cluster. And so what you're basically doing is you would define what resource you want to access, right? So you're SSHing into a production server. You would be prompted to SSO into whatever your IDP is. Teleport would then use that information, say that you're a SRE or a sysadmin, lower level, things like that. And so then you can set some pretty specific permissions as to what you're allowed to do, what commands you're allowed to run. And there's logging information. I'm not explaining this too well right now. I apologize. I would encourage you to take a look at our website. Just gravitational.com/teleport, or you can just play around with the tool itself. It's open source, so you can just download the tarball or just pull it from Quay.
Okay, great. Thank you. We've gotten through all the questions, so terrific. Thank you so much, Virag. That was a great presentation, great Q&A. We really appreciate you being here with us today, and we really appreciate you sharing your expertise. So with that, I would like to thank the audience for attending today's webcast, sponsored by Gravitational and presented by ADTmag.com. Thanks, everybody, and enjoy the rest of your day. This concludes our webcast.